Right, we're now looking at part 2. So part 2 is given that the DE in part 1 holds for the rest of the question. So now this holds. Given that this is a solution. So what do you mean by this is a solution? This is a solution means this satisfies the DE. All right. So when you substitute in this relationship into the DE left hand side equals to right hand side. So this holds. And you're also given A is a constant. Take note that other than A, R, CL are also constant. So we're supposed to show that the constant C is equals to 4L over R2, R squared, where L and R are also constant. This is how do we go about doing that. Okay, so let's take a look at the DE that we have shown in part 1. Maybe we can make use of that. We also should make use of the fact that this is a solution, right? So if this is a solution, then we see that the D also contains the first derivative and the second derivative. So we might start with differentiating this to get di dt as well as the second derivative, so that we can substitute this relationship into this dE, and hopefully in the process of manipulating, we can eliminate some terms and we can get C in terms of L and R. So that is our plan. Okay, so we're going to start with first differentiating I one time and then differentiate another time. Okay, so how do you differentiate? This is the issue, right? Okay, so be focused on what are the constants, what are the variables. So in this case, T is the variable, all right? And of course, I is the variable. So basically, there are only two variables, I and T, right? A, R, and L, these are all constant. So you see this as a product of two terms, because these are product of two variables. AT is a variable, E minus RT over 2, L is a variable because T is a variable. So we're going to use product rule, all right? So you have to use product rule. So for product rule, we will first differentiate the first term. So differentiate AT is just A. And copy the second term plus copy the first term, differentiate the second term. So differentiate E of negative RT to L will be differentiating this power. So differentiating this is minus R over 2L because this is a constant, all right? Constant multiple. So you can treat, like for example, when you differentiate E minus 2T, what do you get? Differentiate this one, you will get minus 2, right? E minus 2T. So we are doing similarly, applying the same thing over here. So we get this one, then E minus R to LT. Okay, so let's simplify a little bit. So this one, we can't do anything. We'll just copy it. And then you see that this is actually I, right? This is actually I. So we're going to replace this with I. So we always try to simplify before we differentiate further. Okay, so now we're going to find the second derivative. So for the second derivative, for the first term, it's just one term with a constant. So we don't have to use product rule, which just differentiate this. So this would be A. So same thing, differentiate E. So this is a constant, take note. Right, R and L are constant. So when we differentiate minus R over 2LT, we get minus R over 2L, which is the constant multiple. And copy this. Okay, then the other term, again, this is a constant. So we are differentiating I a constant multiple of I with respect to t. So that will give us this constant multiple di dt. So the differentiation part is very important. I know it's very confusing because this question has got too many quantities, all right, too many letters. Just be focused. If you can be focused, very sure which are your variables, which are constant, you will get lost in your own working, okay? All right, now that we have found our di dt and d2 I dt2, all right, we can then substitute it into our dE in part 1. So since I equals to this expression is a solution to the d in part 1, therefore our first derivative, let me call this equation 1, and the second derivative should also satisfy the dE. All right, so we're going to substitute. Basically, we're going to substitute this as the I dt, this one as the second derivative, and then of course I to be this into the dE. Okay, so let's do it. So we have L. So I'm going to substitute this with the second derivative here, the whole chunk. Okay. Then plus R. Now, at this point in time, you may say, can you substitute this? You can, but I realized that I have another the IDT here. So I'm going to just hang on. I'm going to just hang on. I'm going to just do the substitution later because I'm going to simplify first. Okay. If you substitute at this point in time, the working might get a bit messy. So I'm going to just hang on to this first. And then I'm going to substitute the I as this. Okay, so let's do a bit of simplification first before we move on. So let's multiply in the L. So I'll get this. So the L cancels off. And the L's gets cancels off. Copy this and copy this. Yeah, working on this question is really tiring. I know that. Okay, don't give up. So we can simplify this first. Try not to skip steps because for this question where there's a lot of tedious manipulation, if you skip step, you might make careless mistake. So I'm going to bring this over. Okay, so I'm going to now make C the subject because I need to find C in terms of R and L and R. Okay, at this point in time, I can sub in. Of course, you can sub it earlier if you want to. I'm going to replace this with equation 1. Okay, so this whole chunk here, I'm going to plug it in. All right. Okay. And the I, in equation 1, there's a I. The I, I'm going to replace it with this one. Okay, so I'm going to do everything together. So I in this, I'm going to replace with this, just in case you don't know where that comes from. Okay, so let me write this. This is I. All right, I'll pause for a while so that if for those who are copying, you can take some time to copy. Well, for those who are done at this point in time, the rest is actually quite simple, okay? You just manipulate and you should be able to get the answer. So if you can't, let me just complete it for you. So you open up the bracket and then you can cancel this term with this term. So this term is gone. So we are just left with this term, which is the negative r squared over 4l. Okay. Then we can cancel this. Negative, negative is positive. That's it. After all the hard work. Okay. So put it together for you. So if you do it systematically, bear in mind which are your constants, which are variable. This question shouldn't be too difficult. Yes, it's tedious, but it's not a too difficult question. All right. So some of y'all might use other methods. So if you didn't get answer using other methods, you may want to check your differentiation. Make sure you have done your differentiation correctly and your algebraic manipulation. There's another method. The other method is to do implicit differentiation. So for this method, method that I've just shared with you, I didn't use implicit differentiation. I just directly differentiate, all right, using product rule. So this other method, let me just bring you through the other method first. The other method is to first take ln on both sides. You can also do that. So when you take ln, you are using the property. So you're seeing it as 3 terms. So you have ln this is L. Ln ABC is ln A plus ln B plus ln C. So I'm using this property, all right, to rewrite it in terms of ln this. Then after that, then I differentiate, okay? Again, same thing, bear in mind that these are constant. So after differentiating, you differentiate another time, but you are doing implicit differentiation in this case. You just take note. All right. So after that, you will replace. So this is from here, equation 1. So you substitute 1. So this from equation 1, you replace it, and then you expand, and then you simplify. Okay, so this method will do too. Implicit differentiation. Okay, let me make it. So for those doing this method, you can also check if you didn't get the correct answer. And this one, yeah. Okay. Yep, so that's all for this question.